Vitamin B5, or pantothenic acid, is an often overlooked nutrient that plays a deeply foundational role in supporting autophagy, particularly through its critical involvement in synthesizing coenzyme A, CoA. While most vitamins assist in isolated steps of metabolism, B5 stands out for its direct impact on the energetic and structural underpinnings of autophagy itself. Through CoA, pantothenic acid enables the efficient breakdown and remodeling of lipids, fueling the very processes that drive autophagic turnover in metabolically demanding tissues like the liver and muscle. This makes B5 not just a background player, but a metabolic enabler of autophagy's core machinery. Coenzyme A is essential for activating fatty acids and feeding them into the mitochondria via SS oxidation, the energy-yielding process that becomes increasingly important during nutrient deprivation or stress, conditions under which autophagy is most active. When a cell initiates autophagy, it often breaks down lipid droplets and dysfunctional mitochondria to maintain ADP production. CoA is the molecule that turns stored or recycled fats into usable energy at this critical junction. Without adequate B5, this transformation falters, leaving cells starved for fuel precisely when they need it most for cleanup and repair. Thus, pantothenic acid helps ensure that autophagy is not only initiated but sustained with an appropriate energy supply. In the liver, where detoxification and fat metabolism are constant, CoA plays a dual role, supporting autophagy and lipid clearance simultaneously. Hepatocytes use autophagy to digest damaged mitochondria, excess triglycerides, and protein aggregates, and they require a robust supply of CoA to activate fatty acids and channel them into metabolic cycles. When B5 levels are optimal, these cycles remain fluid, allowing autophagy to contribute not only to cellular cleaning but also to liver-wide energy production. In this way, pantothenic acid serves as a metabolic glue, connecting the clearance function of autophagy with the liver's need to stay energetically efficient and toxin-resistant. The importance of CoA, and therefore B5, also extends to muscle cells, which depend heavily on mitochondrial quality control. During exercise or fasting, muscle tissues activate autophagy to clear out worn mitochondria and renew contractile proteins. Pantothenic acid supports this by enabling fatty acid entry into mitochondria, giving muscle cells a clean, steady energy source without triggering inflammation or oxidative stress. This nutrient-driven stability is especially vital for aging muscle, where autophagic decline and mitochondrial fatigue often go hand in hand. Sufficient B5 intake can help preserve endurance, strength, and metabolic flexibility, quietly enhancing the body's ability to adapt to stress. Beyond energy metabolism, pantothenic acid indirectly influences autophagy through its role in synthesizing acetyl-CoA, a key molecule that links carbohydrate, fat, and protein metabolism. Acetyl-CoA is also involved in epigenetic regulation, affecting gene expression of autophagy-related proteins such as LC3 and P62. This means that B5 doesn't just feed autophagy, it may also help regulate when and how it occurs, ensuring that cells initiate cleanup at the right time and with the right intensity. These layers of regulation make pantothenic acid especially valuable in organs that experience high turnover and energetic stress. From a dietary standpoint, B5 is found in a wide array of foods: liver, egg yolks, avocados, mushrooms, and whole grains, earning it the reputation of being everywhere. Yet modern diets high in processed foods often lead to suboptimal intake, and because B5 is water-soluble and not stored extensively in the body, consistent daily intake is necessary to maintain its benefits. Mild deficiencies may manifest not with overt disease, but with subtle impairments in mitochondrial performance, fatigue resistance, and autophagic efficiency, all of which affect long-term vitality and metabolic health. What's particularly inspiring is how pantothenic acid exemplifies the body's elegant design, a single nutrient, modest and abundant, supporting complex processes that span cellular renewal, energy generation, and genetic regulation. Rather than acting as a blunt force supplement, B5 works by unlocking the body's own capacity to repair and refuel. This makes it an ideal partner in any approach to longevity that favors nourishment over pharmacology, synergy over isolation. In the context of autophagy, vitamin B5 doesn't push the system, it powers it. It allows cleanup to proceed smoothly, with fuel to spare, and helps keep high-demand tissues like liver and muscle operating in a state of resilience. By ensuring proper CoA synthesis and lipid metabolism, Pantothenic acid supports a foundation upon which autophagy can flourish, not episodically, but continuously. It is this quiet, sustained energy supply that makes autophagy not just a stress response, but a built-in rhythm of cellular renewal, powered daily by the unassuming but indispensable presence of B5.